the second instance in which you can use the cosine rule is when you need an angle and you're given all three sides of the triangle. Now, there's another way of writing the cosine rule by making cos A the subject, and the book says you should use this version when you're in this situation, when you have three sides and you need an angle. The way you reach this is if we write out the original cosine rule, a squared is equal to b squared plus c squared minus 2bc cos A. If we just rearrange this to put b squared plus c squared on the other side, so it's going to be a squared minus b squared minus c squared, and this is going to be equal to minus 2bc cos A, and then we just divide everything by minus 2bc, so therefore it's going to be a squared minus b squared minus c squared over minus 2bc, which is equal to cos of A. And another way you can write this is if you times both the numerator and denominator by the minus in order to get rid of the minus down here, because you don't really like the negative in the denominator. Move it up here, so therefore you times everything up here by minus 1 to get b squared plus c squared minus a squared over 2bc. And this is another way that you can write the cosine rule. Now the thing is, I never use this version of the cosine rule. The reason is I don't really like remembering formulas. I'm not really that good at it. If you are and that's your thing, then please do remember this, as this is an easier way in order to approach a problem when you need an angle and you're given three sides. But what I do when I'm in the exam is I just use this original version up here and then I just rearrange it after I've put the kind of values in. So therefore I don't have to remember two different formulas. It's up to you. So let's do an example of this scenario. Here we have a triangle with sides of 10, 8 and 11, and we need to find the angle theta here. So we can use the cosine rule. A squared is equal to b squared plus c squared minus 2bc cosine A. As you can see for this one, the kind of letters in the cosine rule don't fit with the triangle here because we have B as the angle here that we need to find. So it doesn't actually work with A being the angle here. Now there's kind of two ways you can approach this, because a lot of the time this is going to be the case. If you really like the letter format, you can kind of just create your own letters and just write over it and say this is A, so therefore this is now angle A and therefore it fits with the cosine. Then this is A, and then you can just say this is B and this is C. But the way that I approach it is, remember that B and C are kind of interchangeable. It doesn't matter what order they are. The only important thing is that this side here needs to be the one that's opposite the angle that you're trying to find. So this needs to be little a, and then obviously this needs to be big A, and that's really the only important thing. As long as you sub it in there, it doesn't matter about the other two sides. This can be B and this can be C, or vice versa. And that's the way I just do it, by identifying that kind of pair that are opposite each other. So in order to do this, I'm not going to do the labeling. I'm just going to say that this is going to be A, so this is going to be 11 squared is equal to, and again the order of the other two doesn't matter, so I'll just make 10b, so it's going to be 10 squared plus 8 squared minus 2, 10, 8, and there's going to be cosine of A, which the angle that we need to find is theta. 11 squared is 121, 10 squared is 100, 8 squared is 64, and then it's minus 2 times 10 times 8, which you put into a calculator, is equal to minus 160 cosine theta. We can simplify this further by doing 100 plus 64, which is 164, minus 160 cosine theta. Then we're going to bring the 164 on the other side, you put into a calculator, is going to be minus 43, is equal to minus 160 cosine theta. Then we're going to divide both sides by 160 to get 43 over 160 is equal to cosine theta. And then we're just going to do the inverse cosine. Theta is going to be equal to cosine minus 1 of 43 over 160, which if you put it into a calculator is equal to 74.4. So that is the value of theta. Again, if you want to use the other formula that I showed before, you can, and it would work. I just demonstrated it this way though. But overall, there are two separate instances of when you can use the cosine rule. You should remember these and how to apply them. Now, quite a big piece of advice I have for this chapter is not to get tunnel vision. And what I mean by this is I've been guilty of this before, of just seeing a question like this and just straight away thinking, okay, where is it that I can use the cosine rule? But in this instance, you can't use the cosine rule straight away because we don't know all three sides. And although we know two sides, we don't know the angle in between straight away. So therefore, we can't use the cosine rule straight away. It's not always that simple. Sometimes you might need to use other rules of triangles in order to find other information, and then you can use the cosine rule. So here's a question like this. We can't use the cosine rule because we don't know this angle, but we can easily figure out this angle because we know that all angles in a triangle add up to 180 degrees, and we have the two other angles in the triangle. So therefore, we can just do 180 minus 87 minus 55 is equal to, if you put it into a calculator, is equal to 38. So therefore, this angle here is 38. And now we could just use the cosine rule. A squared is equal to b squared plus c squared minus 2bc cosine A. As you know, two sides and the angle in between. You can do the labelling thing if you want to help, but I just realised that 38 degrees and the x here are opposite each other, so x is going to be A. It's going to be x squared is equal to, it doesn't matter about b and c, I'll just say 13 is b, so 13 squared plus 7 squared minus 2, 13, 7, cosine of 38, which if you put that all into a calculator is equal to 74.58. So x squared is equal to 74.58, and therefore x is equal to the square root of 74.58, which if you put that into a calculator again is equal to 8.6. So x is equal to 8.6, and that's the answer. But see, we had to first use the fact that angles in a triangle add up to 180 degrees. A lot of the time you'll need to do some figuring out before you can actually use the cosine rule, so it's just like Pythagoras or something like this. Now, you could be asked to prove the cosine rule. This is one of the proofs that you could be asked. Now, at the beginning of my A-levels, I didn't actually take proofs too seriously, but then I was asked this exact question in a mock exam, and it completely caught me off guard. I think I lost a lot of marks because of it, because I had no idea how to do it. So I really recommend learning proofs because it's such easy marks if you know how to do it, but if you don't know how to do it, you can lose a lot of marks. So there's quite a few ways you can do this one. I'll use the proof in the book. I use a slightly different method, but that involves knowing sin theta squared plus cos theta squared is equal to 1, which you don't cover until next chapter. So I'm going to use the one in the book, which is a good way to do it too. So let's prove it. We have a triangle ABC here with the opposite sides labelled, and we need to prove that a squared is equal to b squared plus c squared minus 2bc cosine or cos of a. The key to this is you need to draw a vertical line down like this, and therefore these will be right angles. So first of all, we're going to label this here h, it's kind of the height of the triangle, and we're going to label this side here going from here to here, we're going to label this x, and therefore this side here, because we know that this whole side is c, this is going to be c minus x. So a squared using Pythagoras is going to be h squared plus c minus x squared. That's quite simple, because it's just h squared plus c minus x squared is equal to a squared using Pythagoras. By the same logic, b squared is equal to h squared plus x squared here, hx here, the other two sides. If we do b squared minus a squared, it is going to be, if these terms here, it's going to be h squared plus x squared minus h squared minus c minus x squared, which you can simplify this by just cancelling these two terms here to get b squared minus a squared is equal to x squared minus c minus x squared. We can expand the brackets to x squared minus, and let's expand the brackets to c squared minus 2cx plus x squared, and then let's expand the brackets again to do x squared minus c squared. Remember to get all the terms plus 2cx minus x squared. These two cancel out to get 2cx minus c squared. So b squared minus a squared equals to 2cx minus c squared. We're going to move the b squared onto the other side to get minus a squared is equal to minus b squared minus c squared plus 2cx. We're going to times everything by minus 1 to get a squared is equal to b squared plus c squared minus 2cx. This is starting to look quite familiar now, but now we need to know what x is. Well, we can figure this out by using SOHCAHTOA. So here we have x and we need to find what this is, and we know what b is. So using a, if we do the labelling, so this is going to be the opposite here. So this is a right angled triangle. H here is going to be O. This is going to be H, and this is going to be A. Now we know all three sides technically. We have a term for all of them. We have H, we have B, we have X, but we don't really want to incorporate H again because we've already got rid of H, and we need to find a value for X. And obviously we're allowed to use B because that's one of the terms given to us originally. So we're going to ignore O and we're just going to ignore H as well. So it's going to be A and H that we're going to use, and therefore that is going to be SOHCAHTOA. It's going to be the cosine theta is equal to A over H, so cos or cosine of A is equal to A, which is X, over H, which is B, and therefore we can times everything by B to get B cosine A is equal to X, and then we can just sub this in here to get A squared is equal to B squared plus C squared minus 2CB cosine A, and obviously another way to write this is A squared is equal to B squared plus C squared minus 2BC cosine A. And that's the answer. That's how you do it. So again, they could ask this to remember how to do the proof. It can be quite hard to logically figure out a proof from scratch, especially drawing in this line here and labelling the H and the X. There's no kind of logical way in order to think about how you do that. I've tried before to not learn proofs off by heart and just figure them out when I'm in the exam, and it doesn't work. So I'd recommend learning how this proof works and being able to recite it if it comes up. Here's a question on the cosine rule, so pause the video, have a go, and I'll go through the answer in about 5 seconds. Okay, this is a very typical exam question because it has algebra, and at A-level they love algebra. Now really quick, my tip for this is I would read the wordy part of the question to make sure that no information is missing from the diagram that's in the wordy part. In this question it's not the case, but there could be a question where you might miss out on some information that's included in the wordy part. Okay, so like the question I was talking about before, we can't immediately use the cosine rule here because we have two sides and the angle in between, but we don't know anything about this side, and we obviously don't know what x is. That's what we're trying to find. So we need to use other properties of triangles in order to find this side, and we can do that because we have this triangle here. It's a right angle triangle. We have an angle and a side, so therefore we can use SOHCAHTOA. Let's label the sides with this angle in mind. So this is going to be the opposite the angle. This is the longest side of the hypotenuse, and therefore this is going to be A. We need H and we know A, so therefore we don't need O. So therefore this is going to be K, or the cos part, which is cos theta is equal to A over H. Sub in the values, it's going to be cos theta, which is 60, is equal to A, which is 5 over H, which we don't know, so we'll just call it H. Now really quick, if you don't know how to simplify in order to rearrange this, you just put the 5, the numerator over here, as the numerator on this side. It has to be the numerator, so it'll be 5 over cos 60 is equal to H, which if you put that into your calculator, it's equal to 10. So H is equal to 10. And now we can use the cosine rule. A squared is equal to B squared plus C squared minus 2BC cos A. This is the angle and this is the opposite side, so therefore that's going to be the little a and the big A. So it's going to be 10 squared is equal to, remember the order of B and C doesn't matter, so I'll just do x squared plus x plus 2 squared. We're using these two sides here, minus 2b, which is x, and then it's going to be x plus 2 cos 45. We can do a lot of simplifying here. 10 squared is 100, is equal to x squared. We can expand the brackets to do x squared plus 4x plus 4. Then we're going to do minus, and we're going to leave the minus out, and we're going to expand this to get minus 2x squared plus 4x, and this is going to be times by cos 45, which you put into the calculator, or remember from GCSE, is root 2 over 2. We do more simplifying. 100 is equal to x squared plus x squared, which is 2x squared plus 4x plus 4. We're going to leave the minus on the outside for now, and we're going to times this by this. 2x squared times root 2 over 2. You can put it to a calculator or realise that the denominators will cancel out in order to give root 2 x squared, and then by the same logic or using your calculator, it's going to be 4x times root 2 over 2. The denominator will cancel out to give the remaining 2 over here to give plus 2 root 2 x. Then we can expand the brackets to do 100 is equal to 2x squared plus 4x plus 4. Then remember to times everything by the minus to do minus root 2x squared minus 2 root 2 x, put the 100 onto the other side to do 2x squared plus 4x, and then it's going to be 4 minus 100, which is minus 96, minus root 2 x squared minus 2 root 2 x, and this is equal to 0. Now this is a quadratic equation which we can solve using our calculator, but we need to bunch the terms, the x squared, the x, and the lone terms together. So what we're going to do is we're going to write these together to do 2x squared minus root 2 x squared, so that's the x squared terms. Then we're going to do plus 4x minus 2 root 2x, that's the x terms, then minus 96 is equal to 0. And then I like to use brackets here to do 2 minus root 2 x squared, we're just factoring out x squared, plus 4 minus 2 root 2 x minus 96 is equal to 0. And this is now in the form a x squared plus b x plus c is equal to 0, and we can use our calculator in order to solve this, as we now know the values of a, b and c. If we put this into our calculator using the equation function, we will find that x is equal to 5.13 to 2 decimal places, and that's the final answer.